Another place where organolithiums and Grignards behave differently is in the reaction with carbon dioxide. Carbon dioxide is essentially a carbon that's attached to two double bond oxygens, or it's a dicarbonyl species like that. And when you react a Grignard with carbon dioxide, you get a carboxylate, which then you can protonate to form a carboxylic acid. The mechanism is the electrons from the carbon-magnesium bond, again, go to the carbon, and then the electrons go up to either this oxygen, or these electrons go down to that oxygen. And you get a carboxylate. Now, Grignards themselves do not have the power to react with a carboxylate, and so this waits around until you add the acid workup step to protonate the carboxylate, giving you the carboxylic acid as the product. Organolithiums can give you a different product, depends on how much organolithium you add. If you add just one equivalent of organolithium, then you get a carboxylic acid by the same mechanism up above, where the electrons from the carbon-lithium bond add to the carbon, and then the electrons go up from the carbon, one of the carbon-oxygen pi bonds, onto the oxygen, and you get a carboxylate, which then waits around to be protonated. But organolithiums also have the power to punch through a carboxylate resonance. And so if you have excess methyl lithium, you can actually get a different product, where the organolithium adds to the carbon, electrons go up, form the carboxylate, and if you have excess, you can get a second reaction where the electrons from the methyl lithium bond add, and then the electrons go up onto the oxygen, and you get this species with the two O minuses. And this cannot react further and waits around for you to add an acid source. In this case, we can add a mild acid source, since this is a strong base. First thing that the acid source does is it goes through and finds any remaining methyl lithium and protonates that. And then once all the methyl lithium is gone, then, and only then, will you start to protonate these O minuses. And once you protonate one of those O minuses, you have this situation where you can swing these electrons down, kick that OH off, and you get your ketone, where your groups off of the ketone are the same, and they match whatever was attached to the organolithium. This is a way of forming symmetrical ketones. So it's a strange reaction because your actual product is a carbonyl, and typically organolithiums react with carbonyls. The reason you can isolate this particular carbonyl and you can't isolate other types of carbonyl products is the fact that this compound, this product, is generated only after the acid workup step right here and does not exist beforehand. And your organolithium cannot survive the acid workup step, and so as a result, the product and your organolithium aren't present at the same time, and so they cannot react with each other.